Good day, everyone! Welcome to another episode of Learn Math with Doc Gilma. Are you ready, class, for the next lesson? So if you're ready, just sit back, relax, and listen carefully to the topic to be discussed for today. Alright, class, let's begin! The topic I will be discussing for today's lesson is all about solving simple linear inequalities in one variable. What is the difference between linear equation and linear inequalities? In linear equation, class, we are to determine the exact root of the linear equation, wherein we have the equal sign. While for linear inequalities, we are to determine the solution sets of the linear inequality, wherein we simply have the symbols less than, greater than, less than or equal, or greater than or equal. So take note of that. Let's recall the different properties of inequality. Take note, the properties of equality also hold true for the properties of inequality. Number 1, we have the addition property of inequality, or API. Number 2, subtraction property of inequality, or SPI. Number 3, multiplication property of inequality, or MPI. Number 4, division property of inequality, or DPI. Consider a warm-up drills. Solve the following simple linear equations. Number 1, 2k minus 4 is equal to 8. In this given equation, we can simply apply addition property of equality. Add 4 to both sides of the equation. So we have 2k minus 4 plus 4 is equal to 8 plus 4. We can simply cancel negative 4 and positive 4 since they are additive inverse. Cancel out negative 4 and 4. So we have 2k is equal to 8 plus 4. Simplifying further, 2k is just equal to 12 since 8 plus 4 is equal to 12. Applying division property of equality, we can divide both sides by 2. Cancel out 2 since 2 and 1 over 2 are multiplicative inverse. So we cancel 2 and 2. So we have k is equal to 6 since 12 over 2 is equal to 6. Number 2, 5 plus 4p is equal to negative 7. In this given equation, class, we can simply apply subtraction property of equality. Subtract 5 to both sides of the equation. So we have 5 minus 5 plus 4p is equal to negative 7 minus 5. Simplifying further, we can just cancel out 5 and negative 5 since they are additive inverse. Cancel out 5 and negative 5. So we have 4p is equal to negative 7 minus 5. Simplifying further, 4p is equal to negative 12. Applying division property of equality, we can divide both sides by 4. Cancel out 4 since 4 and 1/4 are multiplicative inverse. So we cancel 4 and 4. So we have P is equal to negative 3. since negative 12 over 4 is simply equal to negative 3. Take note, when you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol to make this statement true. Consider the following illustration. We have here negative n is greater than 4. Multiplying both sides of the inequality by negative 1, so we have n is less than negative 4. As you can see, the inequality is simply reversed. Consider negative 2p is less than 4. If we are to divide both sides by negative 2, we can simply cancel negative 2. So we have p is greater than negative 2. Again, since we are dividing a negative number to both sides of the inequality, the less than symbol will become greater than. Consider illustrative example number 1. Solve and graph the following linear inequalities. Number 1. Negative y plus 2 is greater than 0. From here, we can simply apply subtraction property of inequality. Subtract 2 to both sides of the inequality. So we have negative y plus 2 minus 2 is greater than 0 minus 2. From here, we can simply cancel 2 and negative 2 since they are additive inverse. Cancel out 2 and negative 2. So we have negative y is greater than negative 2 since 0 minus 2 is negative 2. Multiplying both sides of the inequality by negative 1, we have y is less than positive 2. As you can see, the inequality greater than is simply reversed to less than since we are multiplying a negative number to both sides of the inequality. Now let's consider y is less than 2, and we're going to graph this in the number line. So given the number line, so we have from negative infinity up to positive infinity. Take note, class, since y is less than 2, we are to draw an open circle to 2 since 2 is not included in the solution set. So from 2, we have the open circle. And we're going to draw a line to the left of 2. As you can see here. Hence, the solution set of y are 1, 0, negative 1, negative 2, negative 3, negative 4, up to negative infinity. Consider illustrative example number 2. Solve and graph the following simple linear inequalities. Number 2. Negative 3x minus 7 is less than or equal to 2. In this given inequality, class, we can simply apply addition property of inequality. We can simply add 7 to both sides of the inequality. So we have negative 3x minus 7 plus 7 is less than or equal to 2 plus 7. From here, we can simply cancel negative 7 and positive 7. Cancel out negative 7 and positive 7. So we have negative 3x is less than or equal to 9, since 2 plus 7 is equal to 9. Applying division property of inequality, we can divide both sides of the inequality by negative 3. Simplifying further, we can just cancel negative 3 and negative 1 over 3 since they are multiplicative inverse. Cancel out negative 3 and negative 3. So we have x is greater than or equal to negative 3. The inequality symbol is reversed since we are dividing to both sides of the inequality by a negative number. So we have x is greater than or equal to negative 3. Consider x is greater than or equal to negative 3. We're going to graph this in the number line. So we have the number line here from negative infinity up to positive infinity. Since x is greater than or equal to negative 3, we're going to draw a closed circle to negative 3, since negative 3 is included in the solution set. So we have a closed circle to negative 3, and we're going to draw a line to the right of negative 3. So we have the line here. Hence, the solution set of x are negative 3, negative 2, negative 1, 0, 1, 2, up to positive infinity. Consider illustrative example number 3. Solve and graph the following simple linear inequalities. Number 3. 3k plus 9 is less than 9 plus 4k. In this given inequality, we can simply apply subtraction property of inequality. Subtract 9 to both sides of the inequality and 4k to both sides of the inequality. So we have 3k minus 4k is less than 9 minus 9. From here, we have negative k is less than 0, since 9 minus 9 is equal to 0, and 3k minus 4k is equal to negative k. So we have negative k is less than 0. Multiplying both sides of the inequality by negative 1, so we have k is greater than 0. Again, the inequality less than becomes greater than, since we are multiplying a negative number to both sides of the inequality. Consider k is greater than 0. We're going to graph this in the number line. So consider the number line here from negative infinity up to positive infinity. Since k is greater than 0, we're going to draw an open circle to 0, since 0 is not included in the solution set. And we're going to draw a line to the right of 0. Hence, the solution set of k are 1, 2, 3, 4, 5 up to positive infinity. before we end our discussion for today, let me first read to you a simple passage from the Bible, coming from the book of Romans, chapter 15, verse 13. May the God of hope fill you with all joy and peace in faith, so that you overflow with hope by the power of the Holy Spirit. Take note, class. Skills are developed through constant correct practice, and there will always be a room for improvement. That's all for today. Stand by for more lessons. Stay safe, everyone, and may God bless us all.